Hi guys, Mr. McIntyre here, going to move on to quadratic equations now. But first of all, I want to take a quick look at quadratics and the quadratic function in general. When we looked at functions, we talked about the different types of functions: straight lines, quadratics or parabolas, and cubics. But for now, we're just going to focus on the quadratic function, or what the graph shape is called as a parabola. So very quickly, both the formulae with the y at the front and with the f of x at the front are ways that you'll see the quadratic function written. We know that the function notation would dictate that we would use f of x more often, but we do need to be familiar with the fact that it's interchangeable with y. Now we're going to look at a lot of complex stuff within the quadratic topic. So I don't want to labor over this point too much. What I do want to just very briefly look at is, or talk to you about, should I say, are the solutions for a quadratic function, or solutions of a quadratic equation, which is exactly what we're going to look at. So a couple of, just as I said, background pieces of information. You'll see on the three graphs we have at the bottom, 1, 2, 3. We have on the left-hand side, we have a positive quadratic or positive parabola, and that's represented by a smiley face. Okay, now this is a single x squared, and it's actually the graph of y equals x squared, or more specifically, y equals ax squared, because we don't know what the coefficient is at the front of it. It's a positive value. It's a smiley face. Any quadratic that has just an x squared, okay, will always go through the origin. Okay. On the flip side, there we have in the middle a negative example of a parabola. Now the graph of this parabola is actually in the form of ax squared plus bx plus c. Obviously, a, however, is less than 1 in this case because it's negative. And the nice thing about these quadratics with the positive and negative, I say nice thing, or the easy way to remember it is, if it's got a smiley face, it's positive. If it's got a sad face, it's negative, and you can have an idea of what to expect when you see the diagram. Now, the third graph there shows a parabola that's positive, but has, and you'll see I've written it's shifted right and down. Okay, so that means we've moved from the origin to the right and down the way. Now, that's just a kind of example put in there to let you see that there will be occasions where these parabolas may be upside down, they may have shifted left and right, and that impacts the equation. Okay, the standard equation we saw before was y equals ax squared. When we start looking at the bigger picture, and we look at the f of x is a squared plus bx plus c, or y equals ax squared plus bx plus c, it's more likely or more often that you're going to see something that's shifted. Okay. The second kind of critical piece of information that we need to look at, particularly if we're going to be dealing with equations, is we need to find, whenever we're dealing with an equation, we tend to be asked in maths for a solution. So with a quadratic equation, it's no different. You still need to find a solution. And I just want to touch on this and what the solutions mean. We'll come to that in the end. But ultimately, what the solutions mean, are what we're looking for here is we're looking for finding the x value, and we can find the x value when we look at the graphs and we find where that graph crosses the x-axis. Now, it wouldn't be over simplification just to put in the axes here. Now, if we're looking for a solution and we're looking for where the graph crosses the x-axis, in the first equation we already mentioned it crosses at the origin. The second graph crosses at 2 different points on the x-axis, as does the second graph. Now, whether it's a smiley face in the case of graph 2, or if it's a sad face in the case of graph 3, still have solutions that cross the x-axis. Now, where do graphs cross the x-axis? This is an important point. We know that they cross the x-axis when y equals 0. And that's important for us to have a think about, because it's going to allow us to adapt our quadratic equations and allow us to get to the point where we can solve them. Well, that's just how it physically looks in a graphical sense. I'll talk to you about that in more detail a wee bit later on. For now, though, I want to go back to the first page we had, where we have our quadratics and the general equation of a quadratic. So we've got y equals ax squared plus bx plus c, and f of x equals ax squared plus bx plus c. Now, most of you will recognize now that the second half here is a trinomial, okay? And what we've done in the past is that we've had to factorize, and that's something I want to look at. And we will indeed be changing the graph with the y into something that has two brackets, and equally the graph with the f of x into an equation that has two brackets. Now, these two brackets represent, in both examples, they represent the factors, okay? And it's from the factors that we will get the solutions, okay? Now, we're going to have to adopt our window method to factorize when we're dealing to solving these equations. We're going to have to be really careful to get that right if we're going to be able to use the factors and the solutions to solve the equation and therefore sketch a graph of a quadratic. These are all the types of things that we're likely to face when dealing with quadratics and quadratic equations. However, probably the most critical element of that is that we want to look at the last piece of information I just gave you, and that was, where is it that the solutions arrive, or where is it that a graph crosses the x-axis? And I said, and I'd circled it in the previous slide, and I said that was when y equals 0. I also said in the first slide that y is the same as f of x. So for both of these, we're looking at y equals 0 or f of x equals 0. Right? So what we're actually going to do is we're going to take this equation and this equation. We're going to end up with 0 equals the two factors. 0 equals the two factors. Now, more often than not, it'll be written with the two factors equals 0. Now, what does that mean? What's happening between these two brackets? What are those two brackets doing? Now, we know that those two brackets multiply. And that goes back to when you were dealing with FOIL. So we've got two brackets that multiply. We have a term on the left-hand side, which is A, term on the right-hand side, which is B. They multiply, and the result, or the solution, or so the answer, is 0. We're wanting to find values where y equals 0. So what impact does that have on it? If we take simply this last section here, we've got a times b, ignoring the fact that it's going to be brackets, and that multiplies to give us 0. What are the possible solutions? So let's look at that in more detail. If I have a times b and that equals 0, what we've actually got is two things that are going to multiply together, two factors, to give a solution of 0. There's two scenarios, or there's three scenarios here. There's number one, where we have the left-hand side has to be 0. Okay? Or in other words, a equals 0, because we have to have 0 times b equals 0. For the solution to the answer to be 0, one of them has to be 0. Or we could have a times 0, and the answer would still give us 0. So b is 0. It's the only way we can get the solution here to be 0. One of the two elements, the a or the b, has to be 0. No, there's also the possibility that they're both 0. 0 times 0 gives us 0. So A equals 0 and B equals 0. So what we actually say there, the solutions can be found in this scenario when A equals 0 and or B equals 0. Okay, one of the factors is 0 or both of the factors is 0. That's ultimately the logic behind this. And these building blocks from the first 3 slides that we've gone through here are exactly what we're going to use to establish the solutions of a quadratic equation. Without them, it could be very difficult. Okay, let's look, although it may seem like quite a leap to jump ahead to the end here, but let's look at a kind of complex real life problem. If we have Jack striking a golf ball, and then the trajectory of that golf ball, I think everyone would recognize on the graph here, it's obviously going to travel a horizontal distance, but it's also going to travel a vertical distance. And as time passes, it will reach a high point and then start to make its way back down to the ground. Okay. Now, as you can see now, that shape, albeit a sad face parabola, okay, is a parabola, and it's a quadratic function. So we're expecting there'll be a squared term in there. And if we look at exactly what the graph is given, the height after t seconds is given by the formula, y equals 20t minus 5t squared. Now that's in the form ht equals 20t minus 5t squared. What do we recognize from the stuff we've already looked at? That's a negative value. So sad face. Forgive me, but I can't help it. Okay, so negative value, sad face makes sense. Okay, where are the solutions to this type of question? If we want to find when the height is 0, then we have to solve the equation. So what we're going to look for is we're going to need the solutions. We'll get to how you would do this type of question a wee bit later on, but where are the solutions? We've already said the solutions arrive when y equals 0. Where is y 0? Along the x-axis. So where are the two solutions? When it started and where it finished. So on this occasion, the solutions are t equals 0, which is right at the beginning, and t equals 4, which is right at the end. And those solutions arrive when y equals 0, or in this case, h of t. And that's something we'll cover a wee bit later. That y is actually represented by h of t. Okay, so the solutions are 0 and 4. There's two solutions because it's a parabola, and more often than not, there's two solutions. There are occasions where you have one solution. Again, we'll cover that when we go through the exercise. I just wanted to show you something, what we're looking to get to at the end, how we can solve this type of problem using quadratics. Now, what we actually need to do is we need to now look at this final bit here, where we know where's that 0 come from. I think we know that because that's h of t is 0. And how do we go from this to these two solutions here? And that's what we're going to do now. Right, guys, let's have a wee quick look at the A and B discussion we've just had a couple of slides ago as a mathematical approach. Now, what we've actually got, if we get asked to solve an equation and we have an equation that has x bracket x minus 6, what we've actually got here is we've got the A is the x and we've got the B is the x minus 6. And we've said before that if a times b equals 0, then either the a equals 0 or the b equals 0, or they both equal 0. So in other words, if we look at the example, we could have x equals 0 because that's the a, which goes straight down to there, and or the x minus 6 equals 0. Now, what those two terms are called, the x is a factor and the x minus 6 is a factor. Now, to find a solution, we solve for 0 for the individual factors. So if we look at this, x equals 0 is fine. We can't do anything more with that. That's a solution. X minus 6, there's nothing outside the bracket, so we can remove the bracket. X minus 6 equals 0. And this is where, once again, changing the subject or solving equations comes in. We've got minus 6 on the left-hand side, so it's going to move to the right-hand side and become plus 6. So actually, the solutions of this equation are x equals 0 and x equals 6. Now, those solutions, okay, obviously translate to something on a graph also. So if we had a graph here, we would have a solution at x equals 0 and x equals 6. Now, this is something we're going to go into at a later date, but then we would need to decide, is this a sad face parabola with a curve going like that, or is it a happy face parabola with a curve going like this? That's for a discussion later, but for the purpose of just solving this, we still look at the and or version. Either the a is 0 or the b is 0. Okay, let's look at an example in full. Example 1, we've got solve 2x squared minus 6x equals 0. 2x squared minus 6x represents a quadratic function. 2x squared minus 6x equals 0 is a quadratic equation. Now, it is worthwhile saying that we could be given this question in a solve f of x equals 2x squared minus 6, or y equals 2x squared minus 6. And to solve, you have to equate to 0. So we've kind of put that into the question already, but that's something that we'll chat about again, that there are times where they may give you a graph of a function with f of x or y, and you have to solve it. What you need to recognize there from what we talked about before, where are the solutions? The solutions occur when y equals 0 or f of x equals 0. So, or f of x equals 0 and y equals 0. Right, focusing on this question, we want to treat the left-hand side on its own as we would, and would look to extract the factors or factorize. So step 1 is factorize. Now, looking at this, is it a trinomial? No. Is it a difference of two squares? There's a subtract in the middle. It could be. Is there a common factor? Yes. So the order that we normally do that was the reverse. So common factor, difference of two squares, trinomial, or common factor, trinomial, difference of two squares. So the first thing we would always check, regardless, is there a common factor? Yes, we can take out 2. What else can we take? We can take an x. So 2x bracket. So 2x, we had in our original expression, we had 2 terms. We've removed the 2x. That means inside the bracket, we're still going to have 2 terms. So 2x times x gives us x squared, 2x squared, sorry, and 2x times negative 3 will give us negative 6x. So now we've factorized, we've now got our 2 elements. If we were to look at this as we had done before, then technically the 2x is the a and the x minus 3 is the b, but we don't need to concern ourselves with that greatly. We don't need to be labeling that throughout the process. So to solve this, either 2x, so we put therefore, or so 2x equals 0 and or x minus 3 equals 0. 2 times x equals 0. If we're dividing through by 2, we get x equals 0. Similar to the last short example, we've got a negative 3. It bounces over to the right-hand side, becomes positive. So our solutions are x equals 0 and x equals 3. Example 2, I'll go through this a lot quicker. So step 1, we want to factorize the quadratic function on the left-hand side. Again, go through our checklist. Is there a common factor? No. Is it a trinomial? No. Is it a difference of two squares? Hopefully, we'll recognize that that's a difference of two squares. We've got 2x all squared minus 3 squared equals 0. which breaks into two factors or two brackets, which we have 2x minus 3 and 2x plus 3. So now we have our a and b. So that means to solve this equation, either 2x minus 3 equals 0 and or 2x plus 3 equals 0. A little bit more complex than what you've looked at before. So we're going to have a division as well as swapping a side. So if we take the 2x and keep it where it is, sorry, and we take the 3 and we move it over, we have to divide through by 2, or 3 over 2 is written as a divide. So we should have our therefore there. Okay, so x equals 3 over 2. Very similar on the right-hand side, except this time we've got a negative 3 when we move the 3. We're still dividing by 2. And what that shows is that when it comes to the graph, okay, when it comes to when we eventually get to a graph, we're going to have symmetry. We've got a negative, sorry, it should be in red. We've got a negative point and a positive point for our solution. This one is obviously negative 3 over 2. This one is 3 over 2. I do want to highlight at this stage that we've got a positive value in front of the x squared, which tells us it's going to be a smiley face. Now, that means we can have a symmetrical parabola, but we don't yet know this point, and we don't yet know some of the other key points on the graph, but we'll get to that as we progress. But for the time being, our solutions are x equals 3 over 2 and x equals negative 3 over 2. Okay, then final example. Hopefully you'll recognize straight away that this is a trinomial, and this may be unfamiliar to some of you, but we'll follow our standard procedure of labeling the coefficients. That gives us a equals 1, b equals minus 2, and c equals minus 3. We'll input those into our window. So we have a times c, so it's negative 3 and negative 2. Our solutions we need in here, we need the top number to be a value, these two numbers to be values that multiply to get negative 3, but add to get 2. So 3 and 1 are going to give us our difference of 2. We've got to make it a negative 3, so one of them has to be negative. The second point where we said there it needs to add to get negative 2. So in other words, the final solution has to be negative, so the larger number has to be the negative. So negative 3 times 1 will give us our negative 3. Negative 3 plus 1 gives us our negative 2. So those are our solutions. Now, we don't have the need for the fraction phase, but for showing consistency, we then take those values on the right-hand side and we stick them into a fraction. And if we can simplify, then we will. Okay. The reason, remember, that this is a 1 is because technically there's a 1x up there, and each of these have to match that. So at the minute, no simplification can be done. So that gives us our brackets. We have x minus 3 and we have x plus 1. Okay, solving them, breaking them individually, that means x minus 3 equals 0 and or x plus 1 equals 0. Therefore, x is 3 or x equals minus 1. And that's our solutions. X equals 3 and x equals minus 1. Now, what does that look like as a graph? Once again, something that we'll get to, but we have a look at that now. Okay, so this would be the graphical representation of the equation from example 1. I'm not sure if you can see it very clearly here, but we've got y equals x squared minus 2x minus 3, and we found that the solutions are what we call the roots, where x minus 1 and x equals 3. Obviously, here we've got a positive value, so smiley face. Here we've got one of the solutions is x minus 1, and the second solution is x equals 3. So smiley face parabola with the roots or the solutions, and I've just added that word roots. I don't want to go into it too much. We'll look at it when we're dealing with the graphs. But the solutions and the roots are x minus 1 and x equals 3. Right, guys, final example. This time example 4, it's a trinomial where the coefficient is larger than 1. And also what we're looking to do is to find the solutions of the following quadratic equation. Now, to find the solution, the reason I wanted to write it like this is to find a solution, we need to equate f of x equal to 0. And I wanted to show you that. So, therefore, 3x squared plus 5x minus 2 equals 0. Okay, so going through our usual process, we have a equals 3, b equals 5, and c equals minus 2. Put that into the window. A times c is negative 6, and b is 5. So two numbers that multiply to get negative 6, but add to get 1. So there's two options here. 3 and 2 will multiply to give us 6, but the difference between 3 and 2 is 1. So we need to look at the second option, which is 6 and 1. So we've got 6 and 1. 6 times 1 will give us 6. There's a difference of 5. So for it to be negative 6, we need to pick one of these two. One of either the 6 or the 1 has to be negative. Now, if we want a positive answer at the end of our addition, then it's always going to be the smallest value that's going to be negative. So let's check that. 6 times negative 1 gives us negative 6. 6 plus negative 1 gives us 5. Excellent. Right, now at this stage we go into the fractions, but because we have a 3x at the start, the 3x goes to the top of the fractions, and we stick our values in 3x over 6 and 3x over negative 1. Now, this one on the right hand side cannot be simplified any further, so it's absolutely fine as it is. However, we can cancel off a 3 on the top and the bottom, which leaves us with x over 2 for the fraction on the left hand side, and now that's in its simplest form. Therefore, we have 3x minus 1 and x plus 2 as our factors. Okay, so let's just do a very quick check with that. 3x times x gives us 3x squared. 3x times 2 gives us 6x. Negative 1x times x gives us negative x, which gives us our 5x. And negative 1 times positive 2 gives us our negative 2. Now, the whole point of this was to find the solutions. Just like we have done before, that means we have to take the left-hand side and the right-hand side and equate them both, or the left-hand side of bracket and the right-hand side bracket, and equate them both to 0. So 3x minus 1 equals 0, and or x plus 2 equals 0. Over here, we have to take the 1 to the right-hand side, so 3x equals 1. X equals 1 over 3. On the right-hand side, we're simply just taking an x equals negative 2 as the plus 2 goes to the other side. So our two solutions are x equals a third and x equals minus 2. So what that means in a graph is that we're going to have a smiley face parabola because of our positive value at the front of the x. We're going to have one of the roots or the solutions at negative 2 and the other at a third. Okay, so smiley face parabola, slightly shifted to the left because of the negative 2. So if we had it on a graph, it would be slightly to the left like this. But again, we're going to go over more graph work. I just want to mention it so that you're at least having a side glance at it.